Before we start, subscribe to Manufacturing Explained for more factory documentaries like this. Hit subscribe and join us as we follow the journey from old cars to new train tracks. Every vehicle here has reached the end of its road life.
Now they become raw material for recycled steel. The first step is mass feed operation into a powerful shredder. Even oversized vehicles are dismantled here with ease.
Inside, hardened steel teeth rip the shells into fragments.
Nothing leaves this chamber in one piece.
What enters as a complete car leaves as small, manageable scrap.
New arrivals constantly replenish the scrapyard's supply. Each delivery brings several tons of future railway steel. Logistics teams choreograph every movement safely and efficiently. Depolluted shells are pushed toward the main feed line.
Here, the vehicles are prepared for compaction and shredding.
Crushing reduces volume and prepares the scrap for baling.
Operators monitor throughput and machine health around the clock.
This press compresses loose scrap into dense cubes called bales.
Compaction makes transport and furnace charging far more efficient. Each bale represents the remains of several vehicles.
These stacks store thousands of tons of ready-to-melt scrap. From here, bales are routed to either shredder or melt shop. Magnets handle loads where forks alone aren't practical.
Ferrous scrap responds instantly to the powerful magnetic field.
Loaded trucks ferry this material to the main steelworks.
An internal convoy keeps the melt shop constantly supplied.
Bales are dumped into feed pits, ahead of secondary shredding.
A steep conveyor lifts the bales toward the shredding chamber.
This enclosed shredder produces uniform fragments for precise sorting. At the discharge, complex shapes become consistent fragments. From here, the material travels to a sophisticated sorting line.
Manual checks remove any oversize or unwanted objects.
Manual checks remove any oversize or unwanted objects.
Powerful magnets isolate the steel from the mixed stream.
Collected steel drops onto a dedicated conveyor.
Stage-by-stage separation improves overall purity. Vibrating screens classify scrap by size for optimal melting. Oversized pieces return for another pass through the shredder.
Non-ferrous metals are separated using eddy current technology.
Induced currents create a repelling force, tossing light metals forward. Air knives remove remaining light contaminants from the stream. At this stage, the steel stream reaches about 99% purity. Clean scrap accumulates in large indoor storage bays. From here, a tunnel conveyor carries the material to the melt shop. At the melt shop, recycled scrap becomes new molten steel.
Preheating reduces thermal shock and saves furnace energy.
Charging buckets gather just the right mix of scrap and additives.
Overhead cranes deliver each charge into the electric arc furnace.
Tons of scrap drop into a furnace built to melt it in minutes.
Graphite electrodes deliver massive electrical power to the melt. Electric arcs reach temperatures hot enough to liquefy steel.
Within minutes, solid scrap becomes a turbulent, molten pool. Lighter slag floats to the top and must be removed. The furnace tilts to tap off impurities into slag pots.
Then, pure molten steel is tapped into waiting ladles.
Suspended above the floor, the ladle moves carefully to continuous casting. Suspended above the floor, the ladle moves carefully to continuous casting. The ladle feeds molten steel into a tundish and caster mold. Steel solidifies into long, semi-finished slabs. Torches cut the continuous slab into transportable lengths. These slabs wait briefly before reheating and rolling. The soaking furnace equalizes temperature throughout the slab.
Even heating prepares the metal for uniform rolling.
Superheated slabs exit, ready for scale removal and shaping.
High-pressure water jets strip off surface scale.
The roughing mill begins shaping the slab into a long bar.
Each pass reduces thickness and increases length.
Guides steer the bar through multiple roughing stands.
Cropped ends remove imperfections before final rolling. Intermediate stands gradually shape the bar into a rail profile.
Slowly, the familiar head, web, and foot of the rail emerge.
The finishing stand locks in exact dimensions and geometry.
A continuous rail strand exits, ready for controlled cooling.
These rails can extend hundreds of meters before cutting.
Cooling is carefully controlled to avoid internal stresses. Temperature drops gradually along a precisely engineered curve.
Straightening machines correct any minute deviations.
Rails are flexed in controlled ways to remove residual bends. A flying shear cuts rails to precise lengths without stopping the line. Timing is synchronized to the rail's exact speed. Cut rails settle onto cooling beds for final ambient cooling.
Supports prevent distortion, while the steel fully stabilizes. Non-destructive ultrasonic tests scan for internal defects.
Operators watch for any signal anomalies inside the metal. Laser profilometry verifies exact dimensions along the whole length. Any deviation from specification is detected within millimeters.
Paint codes mark grade, batch, and customer details.
Automated cranes build stable stacks for storage and shipping. Perfect alignment is essential for safe transport. Heavy steel straps lock each bundle into a solid unit.
Selected rails receive additional heat treatment for demanding applications.
Induction coils heat only the railhead to a precise temperature.
Targeted quenching hardens the surface without over-hardening the base.
Tempering relieves stresses and balances toughness with hardness.
A final straightening pass ensures exact alignment.
Laser feedback guides tiny corrective bends where needed.
End faces are milled to ensure perfect mating between rails.
Multi-spindle drills create precise bolt holes in every rail.
Deburring removes sharp edges that could initiate cracks.
A final wash cleans each rail before inspection and marking.
High-speed air dries the surfaces for protective treatments.
A final scan checks every parameter before release. Only rails that pass these checks move on to shipping. Mechanical stamps imprint brand and traceability data.
A protective coating guards against corrosion during storage and transit.
Loading cradles support rails during road and rail transport. Cranes gently lower bundles into their transport cradles. Wrapping shields rails from moisture and contamination. Flatbed trucks carry finished rails to regional distribution points. Every load is secured according to strict safety standards. Inventory builds up into an impressive landscape of steel. Each mark links the rail back to its exact production batch.
For very long rails, special wagons provide continuous support.
Teams guide each placement to avoid bending or twisting. Mechanical clamps lock rails firmly for the journey ahead.
With loading complete, the rail convoy leaves the plant. These rails travel to construction sites across the region. Rail by rail, recycled steel leaves the mill as critical infrastructure. On site, teams prepare the foundation with sleepers and ballast.
New rails arrive directly from the mill to the track.
Alignment must be perfect to ensure smooth, safe travel. Clips and bolts lock the rail firmly to the track structure. Tamping machines compact ballast to distribute loads evenly.
The line is now ready to carry its first trains.
Soon, passenger and freight trains will rely on these recycled rails. Perfect contact between wheel and rail is crucial for safety. What began as scrapped cars now supports high-speed travel. Recycled steel powers transport systems around the world.